Okay, hello everyone. In a new video, so we have reached part 3 of chapter 6, which is the center of mass for grade 11 students. So on this one we are going to solve some exercises. Then we have reached exercise number 4. They are telling me in the adjacent figure the system is composed of 3 particles of masses. M1 is equal to 1 kilograms, M2 is equal to 2 kilograms, and M3 is equal to 3 kilograms. Determine the position of the center of mass G of the system. So the system is composed of 3 particles given by 1, 2, and 3. And this is done using the Barycenter formula. So we follow several steps that are given by. Then step number 1, which is the reference system. Step number 2 is the coordinates. Step number 3 is to write down the Barycenter formula. And step number 4 is to project. Then as for step number 1, notice that here in this case already step number 1 is done for us, so we are done with the step number 1. Now step number 2 is to write the coordinates of the center of masses of the different particles. So let's start by the particle 1. So G1, the abscissa of G1 is given by 3. Notice that these axes are labeled by physical quantities, and they are given by which is position, which is given in centimeters. So it's given by 3 centimeters and 2 centimeters. Of mass M1 is equal to 1 kilogram. As for the particle 2, so the particle 2 is located at the origin. So in this case the coordinates of a G2 are given by 0, 0, and its mass is given by 2 kilograms. And as for the particle 3, which is located in this quadrant, it has a coordinates of -2, -1, expressed in centimeters. And its mass is given by M3 is equal to 3 kilograms. Then we are done with step number 2. Now step number 3 is to write the Barycenter formula, which is given by OG vector is equal to summation of MI OGI suppressed by the factor which is given by summation of MI. So notice that in this case this is a vectorial equation. Vectors must exist on the left and on the right. And I represents the number of objects that we have. In this case, I runs from 1 to 3. So I is equal to 1, 2, 3. So it's equal to M1 OG1 plus M2 OG2 plus M3 OG3 divided by M1 plus M2 plus M3. So the OG vector is equal to M1 OG1 plus M2 OG2 plus M3 OG3 divided by M1 plus M2 plus M3. So we are done with the step number 3. So this represents X1, Y1, X2, Y2, and X3, Y3. Now this is a vectorial equation and not any type of equation. So whenever we need to project along the x-axis and the y-axis, it will give the birth of 2 equations. So first let's project on the x-axis. So projection along the x-axis. Then in this case, how do we project along the x-axis? Simply we drop down the vectors, and each quantity will carry the label x. Therefore, OGX is equal to M1 OG1x plus M2 OG2x plus M3 OG3x suppressed by the factor M1 plus M2 plus M3. Notice that in this case the masses are scalar quantities, so they don't have projection along the x and y axis. And here in this case, because we are measuring the coordinates with respect to the origin, then this is reduced to the coordinates of the point G, which is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Now let's replace the values. Notice that in this case the positions are expressed in centimeters, so if we replace the positions in centimeters, then the value of xg will be expressed in centimeters. Now the value of m1, which is given by 1, multiplied by x1 is given to be 3 centimeters, so 3, plus the value of m2, which is 2, multiplied by 0, because x2 is given by 0, plus m3, the value of m3 is equal to 3, and the value of x3 is equal to minus 2, divided by the sum of masses, which is given by 1 plus 2 plus 3. So this is equal to 3 minus 6 divided by 6, so it's equal to minus half. Since the position is expressed in centimeter, then the position of the center of mass of the system is given by centimeters. Then xg is equal to minus 0.5 centimeters. Now let's do the projection along the y-axis. Therefore, projection then in this case we drop down the vectors, and each vector quantity will carry the label y. Then OGY is equal to m1 OG1y plus m2 OG2y plus m3 OG3y divided by m1 plus m2 plus m3. And as we have said previously, that since we are measuring the position with respect to the origin, then this can be reduced to the coordinates itself. Then y of the point G is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. Now the value of m1 is given by 1, the value of y1 is given by 2. Now the value of m2 is given by 2, and the value of y2 is 0. The value of m3 is given by 3, and the value of y3 is given by minus 1, suppressed by the factor of 1 plus 2 plus 3. So this is equal to 2 minus 3 divided by 6, which is equal to minus 1 divided by 6. And here let me make the following comment. Although the value of y2 is equal to 0, and it's multiplied by the mass 2, but this doesn't mean that the mass 2 doesn't play a role, because notice that in the fraction, in the denominator, m2 exists. Okay, so the decimal value of this almost is given by So let me say that this is expressed in centimeters. Why it is expressed in centimeters? Because the position is expressed in centimeters, and this is almost equal to 0 minus 0.167 centimeters. So YG is equal to minus 0.167 centimeters. Then the position of the center of mass or its coordinates are given by G minus 0.5 centimeters minus 0.167 centimeters. And what does G represent? It represents the center of mass of the system composed of 3 particles given by 1, 2, and 3. Now let's move to the next exercise, which is exercise number 5. They are telling me a system is formed of a sphere of center O, radius 10 centimeters. So the sphere has a radius r is equal to 10 centimeters. And mass 10 kilograms. Knowing that centimeter is not as a unit of length, in order to convert from centimeters to meters, we divide by 100. So this is equal to 0.1 meters. And mass 10 kilograms. So the mass of the sphere, let's say ms, is equal to 10 kilograms, is joined to a rod AB of length 1 meters. So the rod AB is equal to 1 meters, and of mass m, r for the rod is given to be 2 kilograms. A point mass of 8 kilograms is fixed at point C. So as for the point C, it has a mass 8 kilograms, so the mass of C, of AB, so that AC is equal to 25 centimeters. Knowing that centimeter is not a unit of length, in order to convert from centimeters to meters, we divide by 100. So this is equal to 0.25 meters. They are telling me that M is the midpoint of AB. So we have that this is equal to this. Let G1 be the center of gravity of the sphere. So this is labeled by the object 1. G2 be the center of gravity of the rod. So this is labeled by 2. And G3 is the center of gravity of the point mass, which is given by 3. So number 1. Now here, as you can notice that you are interested in the position of the center of mass. So before we start solving the exercise, let me write on the scratch the steps that we usually follow in order to determine the center of gravity of a given system. Step number 1 is given by the reference system. Step number 2 is to write the coordinates. Step number 3 is to write the Barycenter formula. And step number 4 is to project. Now in number 1, they are telling me determine with respect to A the lengths AG1, AG2, AG3. So let's label the coordinates G1, G2, G3. So the sphere, this is the sphere. So this is the center of the sphere, this is G2. Now because the rod is a homogeneous rod, then the center of gravity is at the center. So this is, okay, the sphere is G1. This is G2. And this is G3. Now notice that here they are telling me determine with respect to A. So it means that A is chosen as a reference as the origin, another point O, okay? Then let's choose A to be the origin. And in this case, let me choose the direction from A to O to be the positive x-axis. And this is the y-axis. Okay, and they are labeled by physical quantities, which is given by meters. Okay, so we are done with step number 1. Yet we didn't answer the question. They are telling me to determine with respect to A the length AG1, AG2, AG3. So AG1 is the length from the point A to the point G1, which is AB plus BG1. So in this case, AG1 is equal to AB plus BG1. Then AG1 is equal to AB plus BG1, which is equal to 1 plus. Now notice that BG1 represents the radius of the sphere, and the radius of the sphere is given by 0.1, so plus 0.1, which is equal to 1.1 meters. Then AG1 is equal to 1.1 meters, in which the point A is chosen as a reference system, as the origin. Now as for AG2 is simply equal to AM, but notice that because M is the midpoint of AB, then AM is equal to AB divided by 2. Then this is equal to 1 divided by 2, which is equal to 0.5 meters. Then AG2 is equal to 0.5 meters. And AG3, which represents the distance from the point A to the point C, which coincides with the G3, and in this case AC is equal to 25 centimeters, which is 0.25 meters. Then AG3 is equal to 0.25 meters. And let me write the results above. Then AG1 is equal to 1.1 meters, AG2 is equal to 0.5 meters, and AG3 is equal to 0.25 meters. So this is it for number 1. Now in part 2 or number 2, they are telling me calculate relative to A the position of the center of mass G of the system. This system consists of 3 particles or 3 bodies. They are given by the rod, the sphere, and the particle C. So which is fixed at the point C. So in order to determine the center of mass of G, we need to follow several steps. You are done with step number 1. As for step number 2, already we are done with it, because notice that in number 1 we have determined the length AG1, AG2, AG3. So notice that now in this case the coordinates of G1 are given by 1.1 meters and 0. So G1 corresponds for the length, it has an abscissa AG1, and AG1 is equal to 1.1 meters. It doesn't have any ordinate. As for G2, which is given by the point M, having an abscissa AM, notice that AM, which is AG2, is equal to 0.5. And as for G3, which is AC or AG3, in this case AG3 is given by 0.25 meters, and it doesn't have an ordinate. So we are done with step number 2. Now as for step number 3, to write the Barycenter formula, which is given by OG vector is equal to summation of MI OGI suppressed by the factor summation of MI. Now the index I runs over the number of bodies that we have, which is given by M1 OG1 plus M2 OG2 divided by M1 plus M2. Sorry, we have 3 bodies. Okay, here the origin is set to be the point A. Let me change the labeling and let me say that AG, okay, it's the same. Let me change the labeling. Then AG plus M3 AG3 divided by M1 plus M2 plus M3. So in this case, AG vector is equal to M1 AG1 plus M2 AG2 plus M3 AG3 suppressed by the factor of M1 plus M2 plus M3. Now notice that this is a vectorial equation. It carries an x component and y component. Then step number 4 is to project. So this equation will give the birth of two equations. Then in this case, projection along the x-axis. So simply we drop down the vector, and each vector quantity, it will carry the label x. And let me say that this is x. And let me say that this is x1, y1, x2, y2, and x3, y3. Okay. So notice now that we are measuring the point G, the abscissa of the point G with respect to A, but what does A represent? It represents the origin. Okay, so in this case, this can be reduced to xg is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Okay, recall that A represents the reference, which is the origin. For this reason, these lengths can be reduced simply to the coordinates. Now, the value of m1 is given by 10, which is the mass of the sphere. And the value of x1 is 1.1. The value of m2, which represents the mass of the rod, which is 2, multiplied by x2, which is 0.5, plus the mass of m3, which represents the mass of the point C, which is 8, multiplied by x3, which is 0.25. All of these divided by the sum of masses, which is given by 10 plus 2 plus 8. Plugging this complicated fraction on the calculator, then we have 0.7. Since everything is expressed in meters, so the value of xg is in meters. Then xg (0.7 meters). Now let's do the projection along the y-axis. Then similarly we can say that AGY is equal to M1 AG1Y plus M2 AG2Y plus M3 AG3Y divided by M1 plus M2 plus M3, which means that YG, which is equal to M1 Y1 plus M2 Y2 plus M3 Y3 divided by M1 plus M2 plus M3. Eventually the values of Y1, Y2, Y3 are given by zeros, so this is 0, 0, 0, then it's given by 0 divided by a number which is 0, then YG is equal to 0. Then the center of mass of the system composed of G1, G2, G3. So notice that all of these belong to the same straight line, which is the x-axis. So expect that the center of gravity must be along the x-axis, and indeed it's away from the point A by 0.7 meters. Finally, they are telling me calculate relative to A, so let's say that AG is equal to 0.7 meters. Let me keep down, and let's move to number 3. Now in number 3 they are telling me determine the value of a point M, the value of a point mass that must be fixed at A so that the center of mass of the system becomes at the midpoint M of the rod AB. So they are telling me determine the value of a point mass that must be fixed at A. So here what we are doing is we are adding another object to the system. So now the system is not composed of only 3 but composed of 4 bodies or particles, and let's say that this particle is given by the particle A, or let me say it's the particle D having an unknown mass md such that it's located at the point D, at the point A. Okay, so determine the value of a point M that must be fixed at A so that the center of mass of the system becomes the midpoint M of the rod AB. We are interested in determining the mass because we know the position. Now in this case, the new center of mass will be given by G so now the system is composed of 3 bodies given by 1, 2, 3, and 4. Okay, and we are interested in determining the value of md corresponding to the 4th particle such that the new center of mass is located at M. Then in this case, the center of gravity G corresponding for this system has the following coordinates: AM 0, which is equal to G. The length of AM is given by 0.5 because the length of the rod is 1. And this is for sure 0 because we have no ordinate. So in this case, so usually we use the Barycenter formula in order to determine the coordinates of G. In this case we have the coordinates of G and we are interested to determine the value of MD corresponding for the 4th particle, knowing that it's being located at the point A. So the coordinates of D are given by 0, 0 because it's being placed at the origin. And now let me use this given in order to solve the problem. So for sure we need to use the Barycenter formula. Then let's write it down. OG is equal to summation of MI OGI divided by summation of MI, which is equal to, now I runs over the number of bodies that you have in this problem, and they are given by 4. Notice that they are given by 4 bodies. So M1 OG1, let me say it's given by AG because the reference is given by the point A. And knowing that we are interested in determining the value of M4, which corresponds for the mass D. Now let's do the projection along the x-axis. In this case, we drop down all the vector quantities, and each vector quantity will carry the label x. Then agx is equal to m1 ag1x plus m2 ag2x plus m3 ag3x plus m4 ag4x divided by m1 plus m2 plus m3 plus m4, knowing that we are interested in determining the mass corresponding for the fourth particle. Now, since A is chosen as a reference system, then you are measuring the distance with respect to the point A. Then these distances can be reduced to the coordinates of the corresponding point, which is given by xg, which is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 divided by m1 plus m2 plus m3 plus m4. Knowing that we are interested in determining the value of m4, okay, corresponding for the fourth value. Now the value of the new xg is given by 0.5, which is equal to the value of m1 is given by 10, and the value of x1 is given by 1.1. The value of m2 is given by 2, corresponding for the mass of the rod. x2, which is equal to ag2, which is equal to 0.5. m3 corresponds for 8. And ag3 is equal to 0.25. Now m4 is the mass that we need to determine, which is, let's keep it as m4 multiplied by ag4. Notice that the point D is being placed at the origin, which is A, so in this case D is set to be 0, 0, so this is simply 0, divided by m1, which is 10, plus 2 plus 8 plus m4. Then this equation can be written as 0.5 multiplied by the numerator, which is 10 plus 2 plus 8, which is given by 20 plus m4, which is equal to 11 plus 1 plus 8 times 0.25 is given by 1, it's given by 2. So in this case 10 plus 0.5 and 4. So what's the type of this equation? This is a linear equation, one unknown, the unknown is m4, which is equal to 14. In this case 0.5 and 4 is equal to 4, dragging 10 to the right hand side, 14 minus 10 is equal to 4. Then in this case m4 is equal to 4 divided by 0.5, which is equal to 8. Notice that previously we have expressed all the masses in terms of kilograms, so m4 will be expressed in kilograms. So in this case m4 is equal to 8 kilograms. Now what does this mean? So previously, without considering the point D, the center of gravity of the system was given at a G is given by 0.7 meters. Now they told us what mass must be placed at the point A in order to shift the center of gravity from here to the point M, and this is given by a mass M is equal to 8 kilograms. So if we place at the point A mass given by 8 kilograms, then the center of gravity will be shifted from this point toward the point M, which is given by 0.5 meters, okay? So we have determined this mass. Now exercise number 6, they are telling me in the adjacent figure the rod AB is uniform homogeneous of mass m1 is equal to 1 kilogram and of length AB is equal to L is equal to 1 meters. So let's start by the first body, which is the rod, and we have that M1 is equal to 1 kilogram and its length AB is equal to 1 meter, which is equal to L. Now the sphere is homogeneous of center C along the straight line AB, radius R. So we have the second body, which is given by the sphere. So its radius, or its, let me start by the mass, which is given by M2 is equal to 600 grams. In order to convert from grams to kilograms, we divide by 1000. So it's given by 0.6 kilograms. And the radius R is equal to 10 centimeters. In order to convert from centimeters to meters, we divide by 100. So 0.1 meters. Now they are telling me determine the position of the center of mass G of the system formed of the rod and the sphere relative to the point A. So they are telling me to choose the point A to be the origin. So, and this consists of several steps. Let me write them down. Step number 1 is to choose the reference system. Step number 2 is to give the coordinates of the different bodies involved in the system. Step number 3 is to write the Barycenter formula. Step number 4 is to project. Okay. Now let's start by step number 1, which is the reference system. So already we have that the point A is the origin, and notice that in the figure they gave me the x-axis, so the y-axis will be just perpendicular to the x-axis at the point O. So this is the y-axis. And now let's write the Barycenter formula, which is given by OG, which is equal to summation of mi. So because, okay, so here we don't have any other label for the point O, so let's say that A is simply given by O. This I didn't do in the previous exercise because already the point O represented the center of the sphere, okay? Now summation of mi OGI divided by summation of mi, which is given by OG, is equal to, now I runs over the number of bodies that we have, and they are given by M1 OG1 plus M2 OG2 divided by M1 plus M2. We are done with step number 3, and we are done with step number 1, but we didn't label the coordinates of these bodies. Now as for the rod, this is the center of the rod. If this is AB, then the center of the rod, which is a G1, so this is G1. Now G1 has the coordinates of AB divided by 2, which is given by 0.5 meters, and of 0 ordinate according to this chosen reference system. And as for G2, now this is G2, and it's away from the point O by the distance AC, which is equal to AB plus BC. Now AB is equal to 1, BC represents the radius of the sphere, which is given by 0.1, so this is 1.1 meters. Okay, now we are done with step number 2, and we are ready to project. So let's do the projection along the x-axis. In this case, vectors, we will drop down the vectors, and each vector quantity will carry the label x. Now, because we are measuring the distances with respect to an origin, then these distances are reduced to the coordinates of the points. So this is xg. Let's say that this is x1, y1, x2, y2. xg is equal to m1, x1 plus m2, x2 divided by m1 plus m2. Now the value of m1, which is given by 1, the value of x1, which is given by 0.5, plus m2, which is given by 0.6, and x2 is 1.1, divided by the masses, they are given by 1 plus 0.6. Now Notice that G1 is here and G2 is here, where we expect that the center of gravity must be located between G1 and G2, and it's shifted toward the heavier particle. So in this case, notice that this mass is greater than this mass, then it will be shifted toward G1. Now plugging this fraction on the calculator, then we have that xg is equal to 0.725 meters. Then xg is equal to 0.725 meters. And now we expect that yg must be 0 because G1 and G2 lie along the x-axis, but let's double check. So xg is equal to 0.725 meters. As for the projection along the y-axis, then OGY is equal to M1 OG1y plus M2 OG2y divided by M1 plus M2, which is equal to M1 y1 plus M2 y2 divided by M1 plus M2, which is equal to M1 multiplied by 0 plus M2 multiplied by 0 divided by M1 plus M2, which is a 0 over a number which is equal to 0. Then YG is equal to 0. So in this case, the coordinates of the center of mass of the system is given by G 0.725 meters and 0. And as you can notice that 0.725 is greater than 0.5 and it's shifted toward, so it's between G1 and G2 and shifted toward G1. Okay, so that's it for me in this video, guys. In the next part we will start by the forces and how do we project a force along the x and the y axis.